Alrighty. Hello, physics. Intro to free body diagrams. I'm going to go over the answers to this because there were a lot. So here's our video. Here we go. What's the correct term for the force of gravity? That'd be weight. Which of the following is the correct symbol for the force of gravity? Fg, force of gravity, Fg. And which direction is it? It's always straight down. A normal force, that's what's keeping you in your chair right now. Your chair is pushing up because your chair is horizontal. But if you were on a slanted surface, then that normal force would still be perpendicular to the surface like this. That's why it's called, there we go, that's why it's called the normal force. And so there's two choices that say always perpendicular. And the thing about the normal force is it can't pull, it can only push. So it's that one. At 330, the length of a force vector shows you the size or the magnitude. Excuse me. 412, which best explains why the diagram shown here must be incomplete? Well, let's look. All right, here is 412. All right, he's pushing to the right. He's applying a force, and yet the dictionary is not moving. So there would have to be some kind of force. Which way? The answer is left. Some kind of leftward force that's keeping it from moving, something that's balancing out this applied force. What could be doing that? What prevents books from sliding? And the answer is friction. And so that is what's missing down here, open, but not in the same direction. Here we go. Boom. 613, friction is necessary to keep the book from accelerating down the ramp. Which way is that? Let's look at the picture again. All right, so which way would friction be acting? It'd be up and to the right over here, right? And that would counteract the fact that the normal force is leaning a little bit to the left, right? You need something to the right to counteract the fact that the normal force is pushing a little bit to the left. So that is what would go there. True or false, the book is not accelerating. It is true. The book is just sitting there. It is not moving. Sorry. It's not changing its velocity, and so it's not accelerating. It's just at rest the whole time. The net force of the book is zero. Also, that is true, and it's not accelerating. Right? So that's how you can tell. And then the last one, all the forces acting on the book are equal in magnitude. That's false. If we scroll ahead a little bit, we'll see that the friction force and the normal force and the gravitational force, they're all actually different sizes. Normal and gravity, they look like they're the same size forces, but actually the gravitational force is a little bit longer. And if you added up the y part of the force of friction, right? Force friction is like this, and the y part would be just this little bit right here, like my thumb. If you add that together with the y part from the normal force, how can I do that? I don't know that I can. Anyway, the y part of the normal force would be about from here to here, or from here to there. And if you add those two together, then they would oppose the force of gravity, and the x part of the normal force is just a little bit from there to there, and the x part of the friction force is just a little bit from there to there, and those two things counteract each other as well. And that's the whole deal. So hopefully that all makes sense. And if it doesn't, come ask me questions. Okay, bye.